In this video, we will explore the supernova explosion that occurred in the Blaze star in 1217 and the possibility of it happening again today. We will focus on the scientific explanations of this historic event, its impact on the universe, modern observation technologies, and the astrophysical significance of supernova explosions. Additionally, we will examine the role of supernova explosions in the universe and future observation projects. Are you ready? Let's uncover the secrets of the Blaze star together. The Blaze star holds a significant place in the history of astronomy. The supernova explosion in 1217 created a great brightness in the sky and was recorded by astronomers of the time. Supernova explosions represent an important phase in the life cycle of stars and help us understand the dynamic structure of the universe. Today, thanks to modern technology, we can examine these explosions in more detail. Throughout this video, we will explore the historic explosion in the Blaze star and potential future explosions. The Blaze star has been carefully observed by astronomers throughout history. The supernova explosion in 1217 attracted significant attention at the time and caught the interest of many scientists. This explosion provided important clues about the life cycle of stars and the structure of the universe. The Blaze star secured an important place in the history of astronomy with this explosion. The Blaze star was notable in the sky for its brightness visible to the naked eye and its dazzling colors. The supernova explosion in 1217 dramatically increased this brightness. This event was eagerly recorded by the astronomers and sky observers of the period. The explosion indicated that the star was in the final stage of its life, releasing a massive amount of energy. The historical significance of the Blaze star aroused great curiosity in the world of astronomy. Following the supernova explosion, many observations and studies were conducted to learn more about the life cycle of this star and similar stars. The Blaze star became an important target for understanding the effects of supernova explosions on star evolution. The supernova explosion in the Blaze star in 1217 created great brightness in the sky, visible to the naked eye. This event was recorded by astronomers of the time, showing the dramatic end of the star's life. The explosion occurred as nuclear reactions in the star's core ceased. The power and brightness of the explosion provided new information about the large-scale structure of the universe to the astronomers of that period. A supernova explosion begins when the nuclear fuel in a star's core is exhausted. The core collapses under its own gravity, releasing immense energy. This energy ejects the outer layers of the star into space, creating a great brightness known as a supernova explosion. The supernova explosion in the Blaze star formed a light show in the sky lasting for weeks. The astronomers of the period made observations and took notes to record this extraordinary event. These observations provided important information about the life cycle of stars. The supernova explosion in the Blaze star became a critical example for understanding how stars evolve and release energy. Supernova explosions represent an important phase in the life cycle of stars. When nuclear reactions in the core of a star end, the core collapses under its own gravity, releasing immense energy. This energy ejects the outer layers of the star into space, creating a massive explosion known as a supernova. This process is a critical event that changes the star's internal dynamics and the chemical composition of the universe. Supernova explosions occur in two main types, Type 1 and Type 2 supernova. Type Y supernovae generally occur when a white dwarf star reaches critical mass due to accumulated matter and explodes. Type 2 supernovae occur with the core collapse of massive stars. The explosion in the Blaze star most likely falls into the Type 2 supernova category. These explosions significantly affect the chemical composition of the universe. Supernova explosions create and distribute heavy elements. These elements play a critical role in the formation of new stars and planets. Therefore, supernova explosions are vital for understanding the chemical evolution of the universe and the distribution of matter. Supernova explosions scatter large amounts of energy and matter into the universe. These explosions trigger the formation of new stars and planets and change the chemical composition of the universe. Additionally, supernova explosions affect the expansion of the universe and the dynamic structure of galaxies. The effects of supernova explosions on the universe are critical for understanding the large-scale structure and dynamics of the universe. The energy released during a supernova explosion compresses the surrounding gas and dust clouds, triggering the formation of new stars. This process plays an important role in the evolution of galaxies. Additionally, supernova explosions can also influence the formation of supermassive black holes at the centers of galaxies. Supernova explosions are the main source of cosmic rays. These high-energy particles spread into intergalactic space, affecting the expansion and dynamic structure of the universe. These particles also influence interstellar magnetic fields and galactic winds, contributing to the shaping of galaxies. A new supernova explosion is expected in the Blaze star these days. Thanks to modern astronomy and observation technologies, we can predict and examine this explosion in detail in advance. This will provide scientists with more information about the life cycle of stars and the dynamic structure of the universe. The expected explosion in the Blaze star is creating great excitement in the astronomy world. A new supernova explosion indicates that the star is in the final stages of its life cycle. This explosion occurs when nuclear reactions in the star's core cease and the core collapses under its own gravity. Scientists use modern telescopes and observation tools to examine this process in detail. The expected explosion in the Blaze star will provide more information about the life cycle of stars and the dynamic structure of the universe. These observations will help us understand how supernova explosions occur and how they affect the universe. Modern telescopes and space observation tools allow us to examine supernova explosions in detail. These technologies help us analyze the physical and chemical properties of the explosion and understand the structure of the universe. Additionally, these observations help us better understand the role and impact of supernova explosions in the universe. Scientists are trying to solve the mysteries of supernova explosions with modern observation technologies. Space telescopes are crucial for observing supernova explosions. Telescopes like the Hubble Space Telescope can capture detailed images of supernova explosions and analyze the physical properties of the explosion. Additionally, these telescopes can be used to measure the chemical composition and energy output of supernova explosions. Ground-based observatories also play an important role in observing supernova explosions. These observatories can track the light curves of supernova explosions and analyze the development of the explosion over time. Modern observation technologies provide critical data for understanding supernova explosions, contributing to the understanding of the dynamic structure of the universe. Supernova explosions play a critical role in understanding astrophysical processes. These explosions provide important information about the life cycle of stars, nuclear fusion reactions, and the chemical evolution of the universe. Additionally, supernova explosions are significant for studying phenomena such as gravitational waves and cosmic rays. The astrophysical importance of supernova explosions greatly contributes to understanding the large-scale structure of the universe. Supernova explosions are critical for understanding the chemical composition of the universe. These explosions create and distribute heavy elements. These elements play a critical role in the formation of new stars and planets. Supernova explosions are vital for understanding the chemical evolution of the universe and the distribution of matter. Additionally, supernova explosions play an important role in studying gravitational waves. These explosions emit strong gravitational waves, causing ripples in the fabric of spacetime. These waves contribute to understanding the expansion of the universe and the dynamic structure of galaxies. The astrophysical importance of supernova explosions greatly contributes to understanding the large-scale structure of the universe. Blaze star will continue to be an important target for future astronomical observations. By studying the supernova explosions of this star, we can gain more information about the life cycle of stars and the dynamic structure of the universe. Additionally, these observations will enhance our ability to predict and understand future supernova explosions. Blaze star will continue to be an important observation target in the world of astronomy. Future observations of Blaze star will allow for a detailed examination of supernova explosions. These observations provide important information about star evolution by analyzing the physical and chemical properties of the explosion. Additionally, these observations help us better understand the role and impact of supernova explosions in the universe. Scientists are developing new telescopes and observation tools to study Blaze star and similar stars. These technologies allow for a detailed examination of supernova explosions and an understanding of the life cycle of stars. Blaze star will continue to be an important target for future astronomical observations. Past supernova explosions have been recorded as significant events in the history of astronomy. Since ancient times, people have observed and recorded the dramatic changes supernova explosions create in the sky. For example, Chinese astronomers recorded the supernova explosion in 1054 AD, which led to the formation of the Crab Nebula. These historical observations laid the foundation of modern astronomy and contributed to the understanding of supernova explosions. The 1217 supernova explosion in Blaze star also holds an important place among these historical observations. Astronomers and sky observers of the period carefully observed and recorded this event. These observations provide important information about the life cycle of stars and the dynamic structure of the universe. Historical observations of supernova explosions have played a critical role in the development of modern astronomy. Supernova explosions leave chemical traces in the surrounding matter. These traces provide important information about the chemical composition and energy output of supernova explosions. Astronomers study these chemical traces to understand the physical processes of supernova explosions and the chemical evolution of the universe. The chemical traces of the supernova explosion in Blaze star allow for a detailed examination of this event. Chemical traces help us understand how supernova explosions affect interstellar matter and trigger the formation of new stars and planets. These traces also help us determine the energy output and intensity of the explosion. Chemical traces of supernova explosions play an important role in understanding the large-scale structure of the universe. Supernova explosions affect not only their own star systems but also the surrounding stars and planets. The energy and matter released during the explosion can compress the surrounding interstellar matter, triggering the formation of new stars and planets. This process plays an important role in the dynamic structure of galaxies and contributes to the formation of new star systems. The supernova explosion in Blaze star also affected the surrounding stars and planets. The energy released during the explosion compressed the surrounding interstellar matter, triggering the formation of new stars and planets. This process influenced the dynamic structure and chemical evolution of the galaxy. The impact of supernova explosions on other stars and planets provides important clues for understanding the dynamic structure of the universe. Future research on supernova explosions will contribute to a better understanding of the large-scale structure and dynamics of the universe. Scientists aim to examine supernova explosions in detail by developing new telescopes and observation tools. This research will help us understand the physical and chemical processes of supernova explosions and their role in the universe. The study of historical events such as the supernova explosion in Blaze star provides important information for predicting and understanding future supernova explosions. This research will help us better understand the energy output, chemical composition, and impact of supernova explosions on the universe. Future research on supernova explosions will help us uncover the great secrets of the universe and understand astrophysical processes. Supernova explosions are among the most dramatic and energetic events in the universe. These explosions represent an important phase in the life cycle of stars and help us understand the dynamic structure of the universe. Supernova explosions in Blaze star are important events that help us uncover the great secrets of the universe and understand the evolution of stars. The place and importance of supernova explosions in the universe create great curiosity and interest in the world of astronomy and astrophysics. Supernova explosions provide important information about the chemical evolution of the universe and the dynamic structure of galaxies. These explosions trigger the formation of new stars and planets and change the chemical composition of the universe. Additionally, supernova explosions play an important role in studying phenomena such as cosmic rays and gravitational waves. The place and importance of supernova explosions in the universe greatly contribute to understanding the large-scale structure of the universe. Thank you for joining us on this fascinating journey. Don't forget to follow the Spacetime channel for more space and science content. See you in our next video. Goodbye.